This is not an easy lesson. Pay attention. All right. So yesterday we talked about what the words meant and how to find them. Today we're going to use them with parallel lines. We already know that linear pairs add to 180, right? We need to figure out what does it mean to be an alternate interior angle. Are they the same or do they add to 180? Those are your two options. Are they the same or do they add to 180? Before I teach this lesson, please pay attention. If you are ever lost and don't think you know the answer, be logical. Do they look like they're the same measure, or do they not look like they're the same measure? If they look like they're the same measure, they probably are equal to each other. If they don't, they're probably adding to 180. Those are the only two options you have. Do you understand that? Everybody got that? So, if all else fails and you can't remember things, be logical. Do you understand that? Because this is a lot to remember, so I know that it is difficult. So we're going to talk about all of these other angle relationships and what it means to be parallel lines. This only happens if lines are parallel. These situations only happen when lines are parallel. Notice on last night's homework, if you think back to those diagrams, none of the lines were parallel, right? They were crossing one way or the other, making triangles, whatever it was. These these postulates and theorems I'm about to tell you do not work unless the lines are parallel. All right? So you're going to be able to justify your solution, and you're going to be able to do the converse as well. So I'm going to skip this so that we can just get started. All right. So corresponding angle postulate. The corresponding angle postulate. First of all, give me a pair of corresponding angles. Somebody give me a pair of corresponding angles. Austin, what is a pair of corresponding angles? 1 and 5 are corresponding angles. For those of you that were not here yesterday, please pay attention. What if I label my lines? Greg, which one is my transversal?
L.
L is cutting the two parallel lines, okay? The transversal is what's cutting the two parallel lines. So L is cutting through both parallel lines. So the transversal is L. So if two parallel lines are cut by a transversal, in this case we're calling it L, right? Then each pair of corresponding angles are congruent. So we're saying corresponding angles are in the same position. Do you see how they're both in the upper left of the parallel line? That's what makes them corresponding. So corresponding angles are congruent, so we're saying the measure of angle 1 is equal to the measure of angle 5. So they are congruent, they are equal, they are the same. Give me another pair of corresponding angles. Give me another pair of corresponding angles. Hayden? 2 and 6. So the measure of angle 2 is equal to the measure of angle 6. Now, those aren't the only ones. Can somebody give you another one? What's the other one that we could do? Yeah. 3 and 7. Perfect. So the measure of angle 3 is equal to the measure of angle 7. I'm going to put that over here. What's the last one that we haven't gotten? Olivia, what's the last one we haven't gotten? 4 and 8. Now look at this. Like I said, be logical. Do they look like they're about the same size? So can't you be logical? Now sometimes they won't be that way, but for the most part, you can try at least to do that. All right, alternate interior angles theorem says if two parallel lines, so notice the words parallel lines are always in here. It's important. This only happens if the lines are parallel. Are cut by a transversal, and we called that transversal L in our case. Then each pair of alternate interior angles are congruent. Each pair of alternate interior angles are congruent. Give me a set of alternate interior angles. Give me a set of alternate interior angles. Greg?
3 and 6.
So alternate, 3 and 6 are on opposite sides of the line. 3 is touching parallel M. 6 is touching N, right? So they're touching two different lines, and they're on opposite sides, and they're inside the lines. So we're saying those two are congruent. So the measure of angle 3 equals the measure of angle 6. Iku, what's the other set there? 4 and 5, opposite sides of the line. L, which is our transversal. Guys, stop. Pay attention. Inside the bread, one's touching N and one's touching M. So 4 and 5. You need to be using your notes. Okay, if two parallel lines, again, notice it's only if the lines are parallel. If two parallel lines are cut by a transversal, and we're calling our transversal L, then each pair of consecutive interior angles is supplementary. What's your question? Or were you going to tell me? Okay, 1 second. First, so Greg, first tell me what supplementary means.
Equal to 180 degrees.
So they equal to 180 degrees. So one angle plus another angle equals 180 degrees. That is what supplementary means. Okay, remember I gave you two options. They're either going to be congruent or equal to 180 as long as they're in these relationships. There's other relationships down here, like the perpendicular one, that will be a little bit different, but besides that. So Carmichael, give me some two consecutive interior angles. Notice the name for this, those of you that weren't here yesterday, is also same side. So it can be interchanged, but that helps you realize that they need to be on the same side of the transversal. Interior helps you to realize it needs to be sandwiched between the bread. Okay? So Carmichael, give me consecutive interior or same side interior.
6 and 4.
So see how 6 and 4 are both on the side of the transversal L, and they're both in between. Okay? So those add to 180. So the measure of angle 6 plus the measure of angle 4 equals 180. So notice that. Do 6 and 4 look like they're the same size? One's acute and one's obtuse. So do they look like they're the same size? So you can be logical. They don't look like they're the same size, then they probably add to 180. Does that make sense, what I'm saying there? Daniel, what's another set of consecutive interior angles?
4 and 6.
We already did 4 and 6. 3 and 5. Then finally, the alternate exterior angle theorem says that if two lines are parallel, so again, parallel lines are the only reason this is happening, and cut by a transversal, which we're calling L, then each pair of alternate exterior angles are congruent, or the same. Emma, give me a set of alternate exterior angles. What? 8 and 3 is not exterior, though. That's interior. So 8 would be with 1. 8 and 1, right? They're on opposite sides of the transversal, and they're both outside the parallel lines. Alternate, opposite sides, exterior, outside the parallel lines. 1 and 8. And they look the same. They're both the obtuse angle, right? So angle 1 and angle 8 are congruent, or equal. So Hunter, what's the other one?
Angle 2 and angle 7.
Angle 2 and angle 7, good. So before I move on to some of these other ones that are down here, do you understand what I mean by be logical? Does everybody get that? Because like I said, it's not always easy. There's a lot of words up here, aren't there? You learned a lot of words yesterday, and a few of you weren't here. So this is very overwhelming for you guys, let alone is it already overwhelming for the other kids that are in here. Do you understand that? So be logical with what you're doing, okay? Just think, all right? What I really want you guys to learn in my classes is to think. So always be able to go past like what I teach you. Be able to think about, does that make sense or not, all right? So the next one is just the perpendicular transversal theorem. In a plane, if a line is perpendicular to one of the parallel lines, then it is perpendicular to another. So all this is saying is if I have two parallel lines, and I know this top one is perpendicular, it forces the bottom one to be perpendicular. Because they are both, do you see how these are both corresponding angles, meaning they're in the same position? And what did we just learn up here? Corresponding angles are equal. So I'm going to say because of corresponding angles. Okay, vertical angles theorem. We know that angles that are opposite each other that form the x are congruent. So those are the same. And we know that if two angles form a linear pair, then they are supplementary, which means they add to 180. All right, go ahead and get that stuff written down, and then when you're ready, we will keep moving along here with doing some examples. Using what we just learned. This isn't helping you.
I know it's not.
Is this not what you guys have first? You have another warm-up?
Yeah.
Oh. We're going to skip that one and go to this then. Yours was out of order then. So we're just going to go to this one. It's just on the bottom there. So it says find each angle measure. So that before you can find them and use those relationships, you have to know where your parallel lines are and which one is your transversal. And there is multiple lines sometimes. So first, Morgan, do we have parallel lines in example 1 here? Yeah, which two are parallel? AG and DF are our parallel lines. So AG is parallel to DF. So which one is our transversal then? Which one is my transversal? Katie, what is my transversal?
It's the line E.
But you need 2 points.
Oh, EB.
Not AB.
EB.
EB. You might probably said that. With transversal EB. You need to know which ones are it so that you guys can easily determine things. All right, so we need to find what x is. So we're going to find each angle measure, but we first need to find what x is in order to do that. So you have to think of different relationships that you know. So tell me a relationship you see in here with these angles that have measurements. So this is 4x plus 22, 70, and 5x. So give me an angle relationship you see here. It could be something from you learned yesterday or something that you've known in the past. Hiku? Right, but that's not a number. These are the you're not wrong. That's not a number, that's just a point there. So we need to look at these three. So what angle relationship do we have? Austin?
4x plus 22 is corresponding to 5x.
Okay, do you guys see that these two are corresponding? What do you know about corresponding angles? They're equal. Do they look like they're about the same? They're both the obtuse angle, right? Do you guys see that? So we have corresponding angles. So we know that because of corresponding angles, (4x plus 22) equals 5x. They look like they're the same. They're both obtuse there. So we can solve for x there. And x is just what? Okay, but does it ask us just to find x, though? No, we need to find the angle measures. You must name angles with 3 letters. So this is angle A, vertex, B, C, or you could use E. So what is the measure of angle A, B, C? If it is 4x plus 22, what do we have to do? What is x?
22.
So does that make sense that this is 110 degrees? Why can you say that that makes sense? Who can tell me why that makes sense that this is 110? Kylie?
Because it's an obtuse angle, so it's over 90 degrees.
1, it looks like an obtuse angle, although we can't assume obtuse and acute, but in this case, it's not, typically is that way, especially on the ACT. Yeah.
Well, the 70 degrees angle forms a line with that angle, so then it should just be 110.
Right. Do you see that this is a line that's formed with the 2 angles? What's 110 plus 70? 180. So it makes sense. And then we need to find the measure of angle D, vertex C, E. Do you guys see that? So measure of angle DCE, which is 5x. So what do we plug in for x? 22. And it should come out to be the same thing. Does it come out to the same as what we got here? So does everything match out okay? Good. Right, questions so far, because they do get harder, so I just want to make sure you're doing okay. Yes?
How many angles like do we have to solve for it to be?
Only the one, I guess you should probably solve for all of them, but after you know a few, it's pretty easy. So like if this is 110 and this is 110, let's solve for all of them just so you guys get used to the relationships here. Let's see here, I gotta choose a different color here. All right, Casey, what's up? That's the name of the line that cuts it. That's just like what they call it. Katie.
Well, angle GB,
GB something, yes,
GB something,
would be,
110.
right, because they're vertical angles, right? Or because they form a line. So if this is 110, what is this one up here? 70, because either vertical angles or a line. So that's the same kind of thing that's going on over here. Well, aren't these two corresponding? So if this is in the same position and this is in the same position, they should be the same. If they're vertical from each other, they should be the same. Or you could say, okay, these add to 180, so that has to be 70. There's so many different ways of looking at it. Katie might look at it differently than Ian, and even Gabe might look at it different than both of them that looked at it. Do you guys understand that? When it asks you for reasoning, you might all have different reasoning. As long as it's correct, it doesn't matter. Do you guys get that? So does that help you out a little bit to see what all those angles are? All right, so let's figure out our parallel lines here and our transversal. Figure out our parallel lines and our transversal here. So what are my parallel lines here? What are my parallel lines here, Jessica? Which two lines are parallel in example 2? Oh my gosh, Jill. That's her sister. And I had her sister, so I call her sister sometimes. Go ahead.
Did you ask for parallel lines?
Yes. At least it makes sense why I called her that. Go ahead.
Line AC and line GD.
Yep. So AC is parallel to GD. And what's the transversal, Jill?
Line FE.
Line FE. Okay, so give me the relationship you want to use to figure this out. Somebody raise their hand and tell me how you want to figure this out, because it's going to be different for all of us here. Helena.
Vertical angles.
Okay, which two are vertical angles here?
CDF and AB.
Yeah, these two are vertical, so what does that mean to be vertical angles?
Equal each other.
They're equal to each other, so she's using the fact that they're vertical angles. So 2x minus 135 equals 75. They both look acute here too, so that makes sense there. Now, do you have to set up any other relationship? Even though there's x's and stuff in here, do you have to set up any other relationship? Or is it when you find x you're good and you can just plug it in? What do you have to do? What are your guys' thoughts? Do you have to set up multiple relationships, or is finding x once okay? Should be finding x once be okay? Yes, because all the x's should be the same. So whichever relationship you see is fine. Is x 95? No, that doesn't make sense. 105? Is that what you guys got? Yeah.
Well, couldn't you just use the vertical angles theorem from the 75 to the vertical angle, and then you know that a line makes 180 degrees, and then just use subtraction, and then the corresponding angles just the same?
Yes, you could. If this had just asked for x, though, you would have needed to find x. Does that make sense? So you still would have had to find that. But yes, you are correct, Katie. All right. So we need to find the measure of all the angles now. So this is A, vertex B, D. So the measure of angle ABD equals 2x minus 135. What did we just find x to be, though? So we can do 2 times 105 minus 135, right? Which is 210 minus 135, which is what?
70.
Does it make sense that it's 75 degrees? Why does it make sense that this is 75 degrees here? Why does that make sense? Carmichael? Yeah, these two are equal to each other, so that should be 75 degrees. And as Katie just said, well, we can use the fact that we have some linear pairs going on here, right? So this has to be 105. Why does that have to be 105? Why do these have to be 105? Gabe, why do these have to be 105? So they add to 180. What's 105 plus 75? 180. Okay, if you are confused, you need to be raising your hand and asking questions. Harmony, do you know then what this would be here? Huh? 105, they're corresponding. Do you see that? Or consecutive interior angles add to 180. 75 plus 105. So what does x minus 30 have to equal, Lindsay? If this is 105, what does this have to be? Yeah, because 105 plus 75 form the line. So then we can finish that off from there. So are there questions on those first two examples before we get on to the next one? All right. These ones are pretty difficult. Yeah.
Oh no, I'm talking about the next slide. And you're not even on the example. Never mind.
Nope. Okay, so you guys want to pay attention to this one because these are difficult. In order to do this problem, you need to cut another parallel line. So in order to do this problem, you need to cut another parallel line through the middle. So that line is going to be parallel to the other two lines. So when you see a problem like this that has an angle going through the two parallels, draw a parallel through its vertex. So go ahead and draw the parallel through its vertex. And then you have some transversals to ignore here a little bit. So if we are just looking at the bottom half here, what is the upper half of angle 1? What is the upper half of angle 1? Morgan, what's the upper half of angle 1? 50, because they are in corresponding positions, right? Same positions. So the upper half there is 50. So then we're going to ignore the lower part. What do you know about consecutive interior angles? What should you know about consecutive interior angles? Consecutive interior angles add to? They don't even look like they're the same size, do they? If I'm covering this up, one's really tiny and one's big, right? So if they don't look the same, they should add to 180 because they're consecutive interior. So to get this angle here, we do 100 plus x has to equal 180, right? Because they're consecutive interior. So what number is that then? Okay, so that's 80. So how many degrees is this whole entire angle then? What is the measure of angle 1? 50 plus 80 is 130. All right, next one here. We have x's and y's, don't we? We have x's and y's, don't we, guys? So you need to find x first and then y. Why do you have to find x first in this case? Why do you have to find x first in this case? Come on, guys. Why do you have to find x first? How many x's do you see in here? How many y's? So why would you have to find x first? There's more x's. You're able to do more with them. So how could we do this? Does anybody have any ideas? Any ideas with our transversal here? Think about what we know. If this upper angle here is 9x plus 12, what is this angle here? 9x plus 12. Why are these two both 9x plus 12? They are corresponding. So what do you know about 9x plus 12 and 3x? What do we know about 9x plus 12 and 3x?
Equal 180.
Do you see the line they're forming here, people? Do you see this? See a line? So they add to 180. So 9x plus 12 plus 3x equals 180. So that's 12x plus 12 equals 180. So that's 168 degrees. What's 12 divided by that? Did you guys get there yet? Anybody? Huh? I think it's 14. Can somebody check me? Is there a calculator? Can you do that for me? Do 168 divided by 12. It is 14? Okay, so then how can we go about finding y? What do we know about y? What two things do we have to add together here? 3x plus... What do you know about, Abby? 3x plus 4y minus 10. What do you notice about 3x and 4y minus 10? They make a line, so what should they add to? So these two should add to 180 as well. But you're seeing that you have two different variables there. How can we figure this out? Why can we figure this out? Hayden? We know that x is 14. And it only asks you to find x and y, so it doesn't matter about what the angle measures are. Okay, questions on that one? All right. The next slide, we have a triangle going on there with some parallel lines. You're going to have to really get good at ignoring transversals. Or like other lines that don't matter. Does that make sense what I'm saying when I say that? Like when I cover things up? Like when we did this one, do you guys notice how I covered this up? And then I covered that up? You have to get really good at ignoring things that are not in the same positioning, okay? Or not using for that part. So it says find x, y, and z. So these two are a parallel line. This is a transversal here. Do you guys see this transversal here? I'm going to use the highlighter and stuff. Do you see the transversal? So we really do not care about this line right now, do we? What do you notice about 61 and 3x plus 1? They're both where? Yeah. They're corresponding. They're both on the top of the line, right? So what do you know about corresponding angles, guys? They look equal, don't they? So they're probably equal. So I have 3x plus 1 equals 61. So we have x is 20. And it tells you that these two sides are congruent. Do you guys see that? That makes this an isosceles triangle. So if they are congruent, that means that the base angles are the same. So if this angle is 61, what does it make y? It also is 61 because of isosceles triangles. So that's something we'll talk more about later, but it's important to know. How many degrees does a triangle have? Who knows how many degrees are in a triangle?
Y equals 61.
Yeah. How many degrees are in a triangle? 180. So z plus 61 plus 61. Almost everything's going to be 180 right now. I know. I can see a clock.
61 plus 20 plus 8.
No. I'm adding up this triangle here. Do you see this triangle here? You guys see the triangle I'm adding in the blue there? So it's 61 plus 61 plus z. So that's 122. So Z equals 180 minus 122. 60, so is that 58? And that's what you get there. So let me talk about this one again. We use corresponding angles to find x. They are equal. If two sides are congruent in a triangle, that means the base angles are congruent. So if these two are congruent, the base angles are congruent. That's why that's 61. This is an upper triangle to the bigger triangle. Do you see how there's two triangles in one here? And triangles add to 180. So triangles are 180 degrees. The next one we're just going to set up. We're not going to actually solve. So I can just run through something real quick with you guys. So this is assume the figure is a parallelogram. Parallelograms have parallel sides. So what do you know about 3x squared and negative x plus 170? What kind of angles are they? If these are parallel, and that's the transversal, what kind of angles are they? They're on the same side, and they're both inside the parallel line, so they're same side interior. Do you see that? Same side interior. Do they look like they're the same measure or no? One looks acute and one looks obtuse, right? So they probably add to, that's what the definition of same side interior is. They add to 180. So we're not going to actually solve this, but they add to 180. Okay, and then just there's some definitions and stuff on the back few pages there. They're just the converses of it. So basically what it's saying is if you know two lines are parallel, then you can say that, or if you know that two things are congruent, then you can say they are parallel based on the converse of the corresponding angles. So since these two are congruent, you can say M and N is parallel. Because they're corresponding and they're congruent, lines are parallel. Converse of the consecutive, if those two add to 180, you can say the lines are parallel. So that's all those ones are saying there. Okay, let me get you guys your homework.